I'd like to speak to you about composition of functions. Composition of functions is a little bit more involved version of function notation, where you're given two different functions and you substitute one function into the other function in place of the variable. So just like function notation, where you take the variable out and we would put a number, we will take the variable out and put a function. And then you simplify, and you only simplify on the right side of the equation. The left side is a very particular way to write y equals. So there's nothing actually to simplify on the left. There are two different kinds of notation for composition of functions, and one of them looks like this. I have f of g of x. That's how you would say it. That could be written this way, and this is the little tiny o. Or you can write f of g of x, and this looks more similar to when we wrote function notation. And again, this is the same idea. I could also ask for g of f of x, where I'm substituting f of x into the g equation. You could also write that as g of f of x. So two different formats, same meaning. The first two, we're putting g of x into the f equation. So the f function is our main template. And this second set, we substitute in an opposite way, so that we're substituting f into the g equation for both of these. And again, works the same way as if you had function notation and you put a number in to a function. Here I have an example. I give f of x, I give g of x. F of x is 3x plus 2, g of x is 4x minus 5. And I'm asking for f of g of x. So I'll put g of x into the f equation. And either way it's asked, it means the same thing. I know what g of x is. G of x is 4x minus 5. So there's nothing to solve for or sort out first. The first thing I'll do is I'll set up the f equation to substitute. F of something is 3 times that something plus 2. And I intend to substitute g of x into the f function. So I put g of x here also, and g of x is 4x minus 5. So I will put 4x minus 5 into the f function. And I distribute. 3 times 4x is 12x. 3 times negative 5 is minus 15. And then I have plus 2, that's part of the f function. I keep that, plus 2. So right now I have 12x minus 15 plus 2. And I can combine the negative 15 and the 2 because those are like terms. They're both constants. So I can write this simplified as 12x minus 13. So here I've found that f of g of x is equal to 12x minus 13. I didn't get a number answer because I substituted something with x. So my answer has x. Let's look at another example. F of x now equals x squared minus 3, and g of x is equal to negative 2x plus 1. I want to find g of f of x. So I plan to put f of x into the g equation. So I set up g to substitute. G of x is negative 2x plus 1. G of anything else would be negative 2 times whatever we substitute plus 1. Again, I plan to put f of x in here. So I put f of x on both sides, and I know what f of x is equal to. F of x is x squared minus 3. So that's what I substitute into the g function. I need to distribute. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 3 is positive 6, and I bring down the plus 1 that was part of the g equation. I can combine the constants, and I find that g of f of x is equal to negative 2x squared plus 7. Let's do another. This one looks a little different. You may want to do these in your notebook and not on the notes sheet if you're short on room. So I realize these are kind of close together on the paper that you're given. Let me go ahead and separate this workout here. Now I want to substitute g of 2 into f. So the first step would be to find g of 2. I don't know what to substitute into f until I sort out what g of 2 is. So I set up the g equation to substitute. Move this over. I can't move it. Phooey. Okay, well, this is function notation. I want to know what g of 2 is, so I take x out and I put 2 instead. G of 2 will be 2 squared minus 4 times 2. 2 squared is 4. Minus 4 times 2 is 8. So g of 2 is equal to negative 4. I'll put g of 2, which is negative 4, into the f equation. I can write it this way now that I know what g of 2 is. So I do function notation again. I'm going to find f of negative 4. F of g of 2 equals f of negative 4. The f equation, f of x, is x plus 3. So f of negative 4 will be, leave a space to substitute, add 3, And g of 2 is -4, so I put -4 into the f function. I find that f of g of 2 is -4 plus 3. That's -1. I'd like you to do g of f of 3. Go ahead and pause the video, work it out, and then we'll check and make sure that our work matches. Make sure that you substitute f of 3 into g, and there will be 2 steps. Please check your work and see that your answers agree with mine. If not, go back. You may need to do a correction. I can also find f of g of 2x. In this problem, I first need to find g of 2x. G of anything is whatever I substitute squared, and I subtract 4 times that I substitute. I will substitute 2x in each space. So remember that when you square something, you multiply it times itself twice. 2x times 2x is 4x squared. And I'll subtract 4 times 2x. So 4 times 2x is 8x. Next, I need to find f of g of 2x. And I've just found that g of 2x is 4x squared minus 8x. So into the f equation, which is a place where you substitute and then you subtract 3, I'll substitute g of 2x, which is 4x squared minus 8x. I have nothing to distribute, and I can only combine like terms. I have one that's squared. Think of that as a square. And I have one that has an x, which is some unknown length. And then I have 3, that's a constant. None of these are alike, so I can't actually combine anything. I'm finished. I find that f of g of 2x is 4x squared minus 8x minus 3.